Hello, this is section 8.2 on polygons. So a polygon is a closed figure in a plane determined by 3 or more straight lines. So it's got to be 3 or more straight lines. So as you can see, this one has 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. 1, 2, 3. At the very minimum, it has to have 3 or more. And that's how you define a polygon. It's got to be a closed figure. The straight line segments that form the polygon are called sides, and the point where the two sides meet is called the vertex. If you want to, for plural, it would be vertices. The union of the sides of a polygon and its interior is called a polygon regional. A regular polygon is one whose sides are the same length and whose interior angles all have the same measurement. So a regular polygon is when the sides are the same length, and the angles have the same measure. Here are some names for different polygons. If you have 3 sides, that's called a triangle. If you have 4 sides, quadrilateral. 5, pentagon. 6, hexagon. 7, heptagon. 8, octagon. 9, nonagon. 10, decagon. 12, dodecagon. 20, icosagon. All right, how do you determine the sum of the measures of the interior angles? There's a formula. So here it is. That's the formula. So if you had a 3-sided figure, it's going to be 3 take away 2. So 3 take away 2 times 180, which is 180. And we already know that the sum of the angles of a triangle add up to 180, and it's confirmed by the formula. Let's see about a 6-sided figure. So a 6-sided figure, that means we'd have to plug in 6 for n. 6 take away 2 is 4. 4 times 180. So 6 take away 2 times 180 is 4 times 180, which is 720. And as you can see, a 6-sided figure has an interior sum of their angles is 720. You can just use the formula to find that out. All right, this is called an acute angle because all angles are less than 90 degrees. This is called an obtuse triangle because one angle is obtuse, this one. Obtuse means between 90 and 180. And as you can see, this one is definitely greater than 90 and less than 180. A right triangle is one that has a 90-degree angle. There it is. An isosceles triangle is when you have 2 sides that are the same length, which means that their base angles are also equal in measure. An equilateral triangle is when all 3 sides are the same length and all 3 angles are 60 degrees each, because 60 plus 60 plus 60 is 180 degrees. A scaling triangle is that a triangle that has no 2 sides equal in length. So this, and this all have different lengths. Two figures are similar if their corresponding angles have the same measure and the lengths of their corresponding sides are in proportion. So C is equal in measure to F, B is equal in measure to E, and A is equal in measure to D. And the corresponding sides are proportional. Maybe this is greater by a factor of 2 or 3. Monique plans to remove a tree from her backyard. She needs to know the height of the tree. Monique is 6 feet tall and determines that when her shadow is 9 feet long, the shadow of the tree is 45 feet long. How tall is a tree? So they have a picture for us on the next slide. Let's look at it. So we know Monique is 6 feet tall. Her shadow is 9 feet long. The tree is what we're looking for, and the shadow of the tree is 45 feet long. So it might be a little bit easier to recreate this triangle. Let me try that one more time. There we go. And then you have this other little triangle here. That's 90. That's 90. This angle is congruent to the small one and also to the big one. So therefore, these two triangles are similar because they share a 90-degree angle. They both have 90-degree angles, and they both have the same. They share a common angle. So that means that all three angles are the same. So that means they're similar. That means their sides are proportional. So we have 6, 9, 45, and we have x. So clearly we're looking for x because we want to know how tall the tree is. So we can set up a proportion. So we can say x is to 6, x is to 6 as 45 is to 9. 45 is to 9. So notice if I start with the big triangle and then I go to the little, big, little, then I have to go big, little, big, little. So big, big on top, little, little on the bottom. I could have also done little, little on the top and big, big on the bottom. So it doesn't matter how you set up your proportion as long as you're consistent. All right, to solve for x, we're going to multiply both sides of the equation by 6 to get rid of the denominator. And that's going to leave us with x equals 45 times 6 divided by 9 is equal to 30. So that tells us that the tree is 30 feet tall. And that's what we're trying to find here. All right, we did that. All right, if corresponding sides of two similar figures are the same length, the figures are congruent. Corresponding angles of congruent figures have the same measure. Okay, we just kind of figured that out. Quadrilaterals are four-sided polygons. Okay, so quadrilateral have four sides, and the sum of the interior angles is 360. Let's confirm that. N minus 2 times 180. That would be quadrilateral is four sides. So 4 take away 2 times 180. It's going to be 2 times 180, which is 360. So it does confirm. We can confirm that that is true. Quadrilaterals may be classified according to their characteristics. So here's a few quadrilaterals. 1, 2, 3, 4. 1, 2, 3, 4. This is called a trapezoid, and that's when you have two parallel sides. So this side and this side are parallel. Parallelogram has opposite sides are parallel. So this side is parallel to this side, and this side is parallel to this side. A rhombus, both pairs of opposite sides are parallel, and the four sides are equal in length. So it's the same as a parallelogram. Opposite sides are parallel, but then they're also congruent. All four sides are the same length. So maybe it's 5, 5, 5, 5. A rectangle, you have both pairs of opposite sides are parallel. Both pairs of opposite sides are equal in length. So these are parallel, and they're also equal in length. These are parallel, and these are equal in length. So the opposite sides are equal in length, and they're also parallel. A square has both pairs of opposite sides are parallel, and the four sides are equal in length. So these are all the same length, and these are parallel, and these are parallel. Okay, in this trapezoid ABCD shown below, determine the measure of the interior angle x, this is the interior angle, and the exterior angle y. Okay, so let's do that. Let's start with angle, angle x. So any four-sided figure we know has interior angle sum of 360. We already kind of did that. All right, and so if this is 90, 90, 130, we should be able to figure out what x is based on the sum being 360. So the angle x plus 130 plus 90 plus 90 must equal 360. 1, 2, 3, 4 angles added up have to equal 360. And now we can solve for x. So if you add up those numbers, you have 130 plus 90 plus 90 is 310. And now you subtract 310 to both sides. X is equal to 50 degrees. So that's the measure. The measure of angle x is 50. And since this is a straight angle and this is 50, well, we know that these two angles are supplementary. That means they have to add up to 180. So 50 plus y equals 180. So y plus 50 degrees has to equal 180 because they form a straight angle. Therefore, they're supplementary, which means that they add up to 180. If we subtract 50 to both sides, we end up with our answer, which is 130 degrees. All right, and that completes this section.